G'day team, welcome to another video. Today we're going to be going through floors. So floors could be a topic which I could spend 5 minutes briefly going over, or I could spend, an hour going over the finer kind of construction details that you'd be, maybe expected to carry out when dealing with floors in an architectural office. So the level of detail that you want to show with floors is totally dependent on the level of detail in which you're modeling a job. So generally speaking, if you're going to be modeling the decking or like the floorboards as their own floor layer and then modeling in the joists and all the bearers and the framing in underneath that, then that's going to be like, that's one direction you're going to head down. Other offices, like the one that I work for, we're going to have the floor joists and the floorboards in just the one flooring element. So they're just layers. So it'll be 20 mil of decking or floorboards, and then 300 mil, for example, to allow for the floor joists. Or some offices would just go 320 mil and just use your imagination. I'll quickly just go over how to actually put floors in and how they kind of work now. All right, so we've got two kinds of floors: architectural and structural. Structural is going to be for more if you're working with some structural engineers on the job, or if you want to have the floor have some more analytical parameters in there. It's kind of tagged differently in the Revit model, whereas an architectural floor is more just kind of your generic, just run of the mill job. I'm sure you'll be able to work out the difference depending on what office you work for and what their standards and expectations are. So also I like the shortcut FL for floor, so we'll tap that in. All right, so this generic floor here, it's just called waffle because it's a 300 mil thick concrete floor, which allows you to have some waffle pods in there, which I'll try and have an image of what a waffle pod slab looks like here so you can understand a little better. You can use any of the line-based drawing tools. You could go around the outside here drawing lines, or you could go pick lines. The method that I like to do when drawing a floor in is the pick walls, because that can also have extend into wall core checked, which I think is pretty handy. So you'd hover your mouse around the edge of the wall, press tab, and then click, and you're done. So you can toggle which core of the wall that line is going to snap to. So if we press this little arrow here, it's going to flip to the inside of the wall, but we would want it being on the outside of the wall because that's where, structurally speaking, the edge of the slab would be underneath the stud line. When we're drawing a floor, it's going to, whatever level we're set to at the moment, it's going to go down from there. So if it's a 300 mil thick floor and we're drawing it at a meter, the underside of that floor is going to be, or 700, whatever. So it's going to go down from that height. It's never going to go up. And obviously you can have some height offset parameters and just pretty generic type and instance parameters with floors. Similar to walls, there can be a bunch of different layers involved in floors, but so we'll just tick OK for that. They're a bit trickier when it comes to brick veneer walls. So which line of this wall do you think that the slab would need to be drawn to? Would it be drawn to the outside of the brick, or would it be drawn to the inside of the brick, or the inside of the wall, or where do you reckon? Have a think. So correct answer is going to be, notice where it says the core of the wall. If we tab select there, this is the correct line for the edge of the slab to be drawn on for a concrete slab in a brick veneer wall, because the brick is going to run down further either into a rebated slab edge or directly onto the footing, however the engineer would design it. But important to not draw the line of the floor in the wrong place, because it's not good. It's not good. Additionally, there's a couple of different little things we can do with drawing these walls here. So you can put a slope arrow in. A slope arrow is pretty much going to define whether the floor kind of travels up or down at a certain angle, or just a certain slope as well. So if we draw a slope arrow in, and we can select it and we go specify either height at tail or slope. So we could say slope is pretty obvious. Slope is just going to be, you know, if we want it to go up at 20 degrees, then it goes up at 20 degrees. If we change slope from height at tail, and then the level at tail is just going to be, you know, whatever level is needed for the job. Height offset at tail, let's just say that's going to be 0, and then the height offset at the head is going to be like 1500. That means that this slab or this floor is going to rise 1500 between the tail and the head of this arrow. So if we were to have a look at that in a section box, you can see how that looks there, which you know, is more like a roof than a floor at that point. But you know, if you're drawing in like driveways or pathways or anything else that needs a slope and is also a floor, that's a handy tool. Keep in mind the limitations of Revit LT. So in the full version of Revit, you're able to edit the well, what do they call them? It's like the point data. So a little tiny node will pop up on each of these corners of the floor, and then you can move them up and down individually, which is extremely handy for manipulating the floor as you need to. But that's one of the very, very hard limitations of Revit LT. I'll also really quickly try and go over some slab edges for you as well. It's a pretty useful tool and good for detailing things properly. So go floor, slab edge, and similar to putting a fascia or a gutter in, it's going to pick an edge of the floor, and you can tab select to put that in on all of the edges. You can see that it's gone blue like around the perimeter there. So as you can see, that's added a little slab edge there, and you can change the profile of the slab edge. It pretty much works exactly like a fascia does. You just select a profile, load it in, and it's going to like attach it to the edge of the floor as with fascias, gutters, a lot of those line-based family tools. Look, without going too deep into the construction detail side of floors, I think that's pretty much covered it. If you're unsure of where the extent to which a floor needs to be drawn, have a look at some construction details online. So for example, look up brick veneer slab edge, or some sort of like, you know, timber framing sectional detail or something. Or even, God forbid, ask your manager or teacher or whoever. Someone should be able to help you out. But drawing floors in, it shouldn't be too hard. But if you're ever unsure about where the edge of the floor needs to go, just ask the question, because it's quite important to place it in the right spot and not to just make a call and potentially get it wrong. But yeah, quick video today. Hopefully you got something out of that, and I'll see you all next time. Thank you as always for watching, and yeah, cheers.